Okay, we're given the function f of x equals square root of x, and we're asked to graph several functions. Y equals the square root of x minus 4, y equals the square root of x plus 4, and y equals 4 square root of x. Now there's another one you're also asked to do, but I'm not going to do that one. Leave that for you to think about. Okay, in any case, f of x equals the square root of x. Now I've sketched these graphs up here, and that's great, but I've got some more board sitting here, and it's going to be better if I can write these a little bit bigger. Now to graph the square root of x, we can easily verify that if x is 0, the square root of x is 0. If x is 1, the square root of x is 1. Most people aren't sure what the square root of 2 and the square root of 3 are, 1.414, 1.732 to 4 significant figures. But then the square root of 4 is 2. So what we know for sure is the point 0, 0, 1, 1, and 4, 2 the points lie on the graph. And the next perfect square is 9, so if we went out a little more than twice this far, we'd be at 9, and we'd have to go up another unit to x equals 3. It's fairly clear that this graph is going to have this sort of a shape. It's actually closer to vertical right here, but at this point, you don't know that for sure. So let's just take this part of the graph. And we'll see why this is close to vertical as we go a little further into the course. In other words, this graph here is actually tangent to the y-axis at the point 0, 0. I didn't draw it that way. I drew it the way people usually do, but it should be drawn tangent. Okay. Now we want to construct the graph of y equals square root of x minus 4. Well, there's a rule that says if you replace x here by x minus 4, that shifts the graph 4 units to the right. And there's a simple reason for that. To get the same number, x is going to have to be 4 bigger. So everything that occurs in this graph occurs 4 units down this way on the other. So if we shift the graph 4 units, that's going to shift the 0, 0 point to here. It's going to shift the 1, 1 point, well, 1 unit over from this, 1 unit up, it's going to be about here. And we can't draw the 4, 2 point as it would be shifted, but basically we're shifting each of these points 4 units to the right. And this would have to shift out to here someplace. Okay, so the graph is going to look something like this. It's going to be just like this part of this graph, but shifted to the right. And I'm not sure I really got the shape right. I think it went up a little too high. Get the idea though. Okay, so what about square root of x plus 4? Well, what this does is it raises every y value by 4 units. So if we raise every y value by 4 units, what are we going to get? Well, we're going to raise this point 4 units. That's going to put us up here. So this point goes up to here. This point goes up 4 units. That puts us up to here. And this point goes up 4 units, puts us up somewhere like about here. And now we can sketch a curve that has exactly the same shape as this curve, well, if we sketched it correctly, and is 4 units higher. So we've raised the graph 4 units. So every point on this graph has been raised 4 units. To do the graph of y equals 4f of x, well, any x value is going to give you the square root of x value that's indicated in this graph. That's going to be the y coordinate, and we're going to multiply that by 4. So every y coordinate here has to become 4 times as great. So let's just pick a few points. Let's pick a point right here. Okay, I'm going to draw an arrow, and I drew that arrow in the same color as my point, but not previously. And I'm going to draw a red arrow here up to this point, and then I'm going to draw 3 more similar red arrows. And this will be the point on our new graph. Now it's clear if I multiply 4 by 0, I still get 0. So my y-coordinate when x equals 0 is still going to be 0. So I'm still going to have a point here. Now let's take a point here. I can draw 4 arrows. Try to get them the same length. I'm not being super careful here. And I'm sure you can do a better job of this than I can, but let's just say that gives us a point up here. Okay, well, I could continue doing this, but if I take these 3 points, and keep in mind that this graph is not exactly leveling off. It never really does level off, but we might expect the graph of y equals 4x to do something like this. So here's y equals 4x. Here is y equals x plus 4. And here is y equals, and there's square roots in there, square root of x minus 4. Okay. And this is wrong, I've got to fix that. It's the square root of x plus 4, not the square root of x plus 4. So I'm going to fix that off camera. Okay, the square root of x plus 4 to match what we have over here. I've written out the basic idea of the rules. Again, if we replace x by x minus 4, we shift the graph 4 units to the right. If we add 4 to the square root of x, our original function, that adds 4 to every y value, so it shifts the graph up 4 units. And for f of x multiplies every value of the square root of x by 4, moving each point 4 times as far from the axis. Isn't very good there. Okay, let's. So what's happened? This point is now 4 times as far from the axis. This point is 4 times as far from the axis. We haven't graphed this point, but if we do this, 1, 2, 3, well, I didn't go high enough, but you get the idea. And you see how you would construct these graphs.